Hey, let's continue the 2016 practice calculus AB examination, section 2, part A. This is free response question number 2. This is the last free response question on section 2. There's only 2 problems for the free response question where you actually get a graphing calculator, and this is the last one. Whew! Good thing we get to use it, okay? So after this, we're going to do section 2, part B, which is problems or free response questions 3, 4, 5, and 6. There will be one video each for each of those as well, and we will not get a graphing calculator. So after this video, the separation anxiety is real. All right? Like the video, that helps me, and you know what? Follow me. That helps you. That helps you know when I put up the next videos, because you get the notifications only if you follow me. And you know what? If you're going to follow me, you might as well like these things. And then I look at analytics, and I'm just like, oh, people like me. It's cool. Let's start question 2. If you have watched any of my previous videos, you know how I feel about graphs and tables and graphics. I love them. Love them. Number 2 states, a store tracks the sales of one of its popular board games over a 12-week period. The rate at which games are being sold is modeled by the differentiable function g, where g of t is measured in games per week, and t is measured in weeks. T, the interval for t, is from 0 to 12 inclusive, meaning it includes 0 and 12. Values of g of t are given in the table above for selected values of t. Approximate, okay, 2a. Approximate the value of g prime of 8 using the data in the table. Show the computation that leads to your answer. All right, let's go here. You know I'm in love with the calligraphy pens and the highlighters. Whew. All right, this word right here, approximate, tells me I can't find an exact answer. I can take the derivative of an equation, but we don't have an equation. We simply have a table, all right? So approximate means we're going to give our best answer without being 100% certain because we don't have an equation to take the derivative of. Notice I've said derivative a couple of times. The derivative of g is the same thing as the slope. It's synonymous. It's a rate of change. Where do I want the slope of g? At 8. I don't even have 8 on my table. If I did, 8 would be right here, okay? So if I want to find the slope at this point, I am just going to take the 2 closest points to it and simply do a change in y over change in x, like an average rate of change, okay? I'm going to get the closest average that I can to 8 by taking the closest 2 points I have to 8. All right, so we'll call this x1, we'll call this y1, call this x2, and this y2. And I'm simply going to do the change in y over the change in x. All right, so we'll do 2100 minus 900, and 10 minus 6. That's 1200 over 4. There you go. There it is. Show the computations. There be the computations that lead to your answer. Geez, thanks, Mr. AP. Maybe it's Mrs. AP. Maybe it's Miss AP. You never know. But thank you for allowing me to use a calculator on this problem. Really means a lot. You son of a guns, yeah. 2b. Approximate the value of the integration from 0 to 12 of g of t dt using a right Riemann sum. Okay, if I see right Riemann sum, I'm thinking RAM. Okay, with 4 subintervals indicated by the table. Explain, using words. I know I love using numbers, but let's use words. Explain the meaning of what that integral represents in the context of the problem. All right, well, let's bring our table back up. Here we go. Right there. Now, anytime I integrate something, integration is like area under the curve. In fact, when you went over content before we started reviewing for finals, we introduced integration by talking about MRAM, which is the middle value, LRAM, which is the left value, and RRAM, which is the right value. We're adding up all those rectangles under the curve. Okay, so this area under the curve is a great approximation. Again, I use approximation. Why? Because they're telling me to approximate. If I wanted it exactly, I would have to integrate an equation. But we don't have an equation, so we're going to approximate it using this table. Now, 4 subintervals indicated by the table. Okay, let's go. This light blue will do. Here's the first subinterval. I should do these different colors, but this is subinterval 1. Here's subinterval 2. I should go here so you can see it. Now I'm just being a perfectionist. Okay, subinterval 3. Okay, that's subinterval 3. And subinterval 4 right here. Okay, these are the 4 rectangles of my areas under the. I love that these are horizontally written in the table, so I can make these rectangles out of it. It's awesome. These vertical rectangles across the horizontal table. Now, anytime I use RRAM, okay, okay, I've got to look at the right value. So let's take a look at the first subinterval. We have 2 values. I want the right one, 450. Okay, and I'm purposely going to leave some space here, and I will explain why in a moment. The second subinterval, I want to look at the right value, which is this one. Okay, I have 2, and the right one happens to be 900, so I have 900. I'm going to add that. Okay, and I'm leaving space intentionally. All right, let's look at subinterval 3. I have the left and the right value, but since this is RRAM, I'm going to add 2100. And let's look at subinterval 4. Right here, I have 2, the left and the right, but since this is RRAM, I'm using the right one, and I'm going to add 2400. Okay, now, let's not forget, we need to multiply our sum, this addition, by the width. And if these were all this, if these were all the same width, I would take it and multiply it by whatever that width is. Okay? But they're not all the same width. That's where the problem comes in, and that's why I left space here. This has a width of 3. So my 450 is going to get multiplied. Yep, I said 450. And I started to write the 4 after pointing out that the width was 3. So 3 times 4. This width is also 3. I mean, I could have distributed the 3 here, but let's just, for the sake of the problem, write it out like this. Okay, still get the same answer. This width is 4. And this width is 2. Well, guess what? I mean, we could do that in our head, but shoot. They told us we could use a calculator, Lightning, so he's going to use a calculator. Hey. Sorry, I couldn't help it. I'm so sorry. I would go back and edit that out, but I'm not going to. I'm going to leave it in there. Here we go. View, detached LCD, and I am going to turn this on and add that equation that I've written that's just cut off at the bottom there. I'm going to take 3 times 450 plus 3 times 900. Now, the biggest thing is when you're typing into the calculator, and that is plus 4 times 2100. See, I got to make sure this is right. And then, okay, the biggest thing is when you're typing into the calculator, make sure you don't accidentally press an extra number, or plus 2 times, is that 2400? It's 2400. Okay, 2400. Okay, so I just like to look up because it's real easy for me when I try to hit plus, the plus doesn't go in or something like that. Don't leave it up to just a simple little error if you got your math set up right. Okay, so the answer is 17,250. So we go back here. 17,250. Now, explain the meaning of this. I have written this time and time again. If I integrate my rate, right? We're integrating the rate, games per week, right? If I have games per week and I integrate it, I'm going backward, that just gives me the unit, which is just games. Okay, so that's 17,250 is games. But now we need to explain what that actually means in the context of this problem. Well, my bounds are from 0 to 12. So from week 0 to week 12, the area under the curve will represent the total. So from week 0 to week 12, they sold a total, because we totaled this, we added this all up, a total of 17,250 games. That could have been written one of 1,000 different ways. That's just the way that I wrote it. 2C. One person believes, there's always one person, but one person believes that starting with 2,400 games per week at time t equals 12, the rate at which games will be sold will increase at a constant rate of 100 games per week. Per week. Per week, per week. Okay? Based on this model, how many total games will be sold in the 8 weeks between t equals 12 and t equals 20? All right. There is such a little snag in here if you don't pick up on it that it's crazy. All right. First of all, I did not stutter or make a mistake when I said games per week, because this, okay, is g of t, the rate, and this is g prime of t. So we're going to integrate. Okay, we're going to integrate this to get games per week. Why are we going to integrate? Because how many total games? I want to figure out games. Let's not forget that g of t was in games per week. Okay, so again, I'm going to integrate this to get my games. I only have a table. I do not have an equation. This doesn't say approximate. Okay, so I'm going to have to integrate some sort of form, okay, of what this one salesperson believes. Okay, from week 12 to week 20, but be careful here and in these 8 weeks is where you might get tripped up. Okay, let's first come up with an equation. Okay, so starting at 2,400 games, if I go back here, you see at week 12, there are 20, he's saying, okay, right here, starting at this point, week 12 to week 20, which I don't have any data here, so I can't even do like RRAM or MRAM. Okay, they want to know how many games, all right? So, do I still have this? Let's see. Paste. Oh, I do. Wonderful. Wunderbar. Yeah. Okay. So I'll put this here. So this dude, this girl, this they, I don't care who they are, but they're talking some math numbers, and I like them. I like them a lot. Okay. So starting here, during the next 8 weeks, from week 12, from week number 12 to week number 20, okay, we're going to try and total this up, and I'm going to integrate to add, all right, all that stuff up. If we start with 2,400 games, we're starting here. we start with 2,400. Then there's a constant rate of 100 games per week. So plus 100, and here's where people are going to get messed up, T. Okay, that would work, okay? And this is where I said you got to be careful. If I put 2,400 here plus 100 T, dt, okay? I cannot put 12 and 20 here. Why not? Because time, all right? Starting at time 12. If I start at time 12, that's my 0 where I begin. If I put a 12 in here, let's look at my equation here. If I put a 12 in here, that's 1,200 that I'm adding to 2,400. Okay? But we're starting here. Okay? Like at week 1, there should be another 100 more video games, right? Another 100, so this would be 2,500. If it's constantly 1 week, right? At week 2, there's another 100, so now I'm at 2,600. Okay? If we're starting at week 12, I should be adding nothing at that point, not adding 1,200. Okay? So if I use this equation I have right here, the 2,400 plus 100t, I need to begin at 0 and go to 8. This takes care of the previous 12 weeks. All right? Now, what if you want to use 12 and 20? What if you want to use 12 and 20? Then I somehow got to figure out how to make this a 0 when my t is 12. Okay? Let me explain that one more time. I need to make, at week 12, 0. And at week 20, it's 8. And guess what? At week 13, it should be 1. At week 14, it should be 2. I would have to write it like this. Plus 100. Whatever t is, I just subtract the 12. So if this is 12, I get 0. If it's 20, I get 8. If it's 13, I get 1, and so forth. So if I want to use my bounds as 12 and 20, oh, yep, that's okay. There you go. Then I better make the expression t minus 12 dt. I could have done this, or I could have gone from 0 to 8, 2,400 minus 100 t dt. Either one will give me the same answer, but you need to be careful with that, okay? First time I did this, I came over to like a 30,000, and I'm like, I'm like, what's wrong? What did I do wrong? And I looked, and then the light bulb went off, and I said, I was going fast, and I made a boo-boo, and that's what happens when we go fast. And if any teacher on here tells you they never make mistakes, immediately unfollow them and don't like any of their videos, because that's how people learn. You make mistakes. All right, here we go. Let's turn this on. I'm going to go to Math 9. And I'm going to do this from 0 to 8. And I'm going to do 2,400 plus 100x dx. And I'm going to hit enter. I should get 22,400. That's the answer. Okay? Now, what if I come up here and I hit enter because I'm a little bit on the lazy side, and I change my bounds? Okay? I change my bounds from 12 to 20. So the upper bound is 12, or 20, I'm sorry, the lower bound is 12. But remember, I need to change this. Now it's x minus 12. So you can do it either way, but you need to make sure your variable, your expression matches. What happens if I do this, but I don't subtract 12? What happens if the bounds are 12 and 20, but I don't subtract that? You get 32,000. And when you rip through this quickly without even looking at things, and you think you know everything without reading it and really understanding it, that's probably what you would end up with. But it's 22,400. that was a little lesson in life, kids. Don't rush through things. You'll be fine. I mean, hey, look, I turned out to be okay. I am, really. 2D. Another salesperson, everybody's got an opinion at this place, believes the best model for the rate at which games will be sold in the 8 weeks between time equals 12 and t equals 20 is m of t, which is 2400 e raised to the negative 0.01 times t minus 12 squared. Wow, games per week. That is nuts. Based on this model, how many total games to the nearest whole number will be sold during this period? This problem is so much more straightforward and less tricky than part C, because I am just going to integrate. Remember, I'm going to want the total. How many total games I'm integrating m of t. And guess what? I'm going from 12 to 20. How come? Your exponent is set up as t minus 12. That's even easier. Maybe they're trying to get you to double check yourself, maybe to kind of cause uncertainty in your mind, like, oh, the last problem, I was going to do 0 to 8, you know, and I made it 12 to 20, and I had to subtract. Like, I don't know why, but this one is a million times easier, especially since we get to use a calculator. So in my calculator, I'm just going to go to Math 9 again, and I'm going to go from 12 to 20. I think the toughest part in this problem is typing in the equation without making an error. 2400 e raised to the negative 0.01 parentheses x minus 12 parenthesis squared. I'm going to type that exactly as they give that to me. Okay, and that's it. dx. And you know what? I'm just to be safe, I'm going to look at my paper and make sure it's 2400 e to the negative 0.01 x minus 12. All right, yeah, hit enter. 15,784.07. We'll call that 0.077. So that is 15,000, right? 784.077 to the nearest whole number, which is weird. The calculus exam really never asks you to round, but given the context of the problem, you can't sell 0.077 of a video game. So it's 15, or board game, 1,784 games. We are done. Like this video, ring that bell, ring-a-ding-ding, and follow me so you will be notified when I put up the video for question 3. Remember, no calculator. Question 4, question 5, and question 6. There's still 4 more videos I got to come up. Like me, kids, so you get those notifications. I mean, I won't personally tell you. You know, YouTube will, but, you know, I mean, if you want me to call you, drop your number down in the comment. I'm not calling you. Stop it. Stop it. Just follow me. I'll see you for problem 3.